Hi, this is Adam Griffin with the first video for this week, and we're going to be doing problem number 1. And it deals mostly with basically just taking values like density and mass and turning them into volume and height based on area and everything. So we'll dive right into that. So the question is, a barge and its load of iron has a gross weight of 5,000 metric tons. And 1 metric ton is equivalent to 1,000 kilograms. And we assume that the barge and load are made entirely of iron, and while in a closed lock, so no water can go in or out, the barge springs a leak, and it is sinking to the bottom of the lock. So we know the cross-sectional area of the lock, which is 15 meters by 40 meters, and we know the density of iron, which is 7,800 kilograms per meter cubed. And after the barge sinks, will the water level in the lock change? And if so, how much will the water level increase or decrease? So obviously, if you have something floating on top of the water that has volume and it sinks, the water is going to rise by the exact same amount of volume that the object that sank had. So because we know the weight and we know the density, we can divide the total weight by the density to get the volume in meters cubed. So 5 million kilograms, which is 5,000 metric tons, divided by our density gives us a volume of 641 meters cubed for the total volume of the barge and the load. So this is how much of the water is displaced. So to figure out how much that will change the water level, we have to find the cross-sectional area of the lock. So it's 15 meters times 40 meters, and that gives us 600 meters squared. And then to find the amount that the height changes in the lock, we can multiply the difference in the height by area, or we can solve for the change in height by dividing the volume of our barge and load by the cross-sectional area of the lock. So we can do that, 641 divided by 600, and we get that our change in height is 1.07 meters. And we know that it's rising because there is now more volume underneath the surface. So it goes up by 1.07 meters. So that is how you do problem number 1. Pretty straightforward. I hope it was clear, and thank you.